it will be very satisfying to now say that entropy is somewhat, hand wavily a measure of disorder.
That's the term I was looking for. Yeah.
So if you can imagine, like the natural log of 1 is 0. Okay, so the entropy of this coin system that has the macro state of just all heads, that has a multiplicity of 1. So, you plug that into the entropy equation and you get an entropy of 0. Now, as soon as you start flipping coins into different macro states, you'll have higher and higher multiplicities, and it will be you will have higher and higher entropy for those specific macro states. Now, if I were to tell you, you start off with your coins all on the heads, all on the heads flipped up, right? And then you just, you put those coins outside, for example. You just leave them outside, and then you check 10 years later, okay? What are the odds that you come back and you find all of those coins still heads facing up on the street, right? Exactly where you left them. Very low. Very, very low. Because, the wind can blow. Someone can, flip the coins as they wish. The rain could, I don't know. Anything could happen. Literally anything. And so this is kind of an example where it's so much more probable that over time you will find your coins in a different macro state with automatically higher entropy. That I think another really good example is if you have like a stack of papers on your desk, like what are the odds? Let's say you leave like a window open, or not even, right? You leave that stack of paper perfectly ordered and squared off on your desk.
Okay.
And then, anything can happen that can, blow the paper, blow the papers all over the room.
Okay.
I'll say, a tornado, whatever. Anything can happen. But it's so easy to go from that perfect orderly state to a disordered state. But you'll never see a tornado swirl up those papers back into a perfect stack. Because that would be decreasing the entropy.
That is true.
Of that paper system.
Let me give you an easier example. Much easier.
I thought that was pretty easy.
I mean, okay, that's okay. I mean, I don't know, the tornado came into it and everything, but if we're just think about a deck of cards. Think about a deck of 52
This
cards.
is the exact same argument, by the way.
Yes, it is. It's the exact same argument. It's just an easier analogy to understand. Okay. So think about 52 cards. We have a deck of playing cards. It's a brand new stack. So what do we know about this stack? We know where every single card is, right? We know where the king is, we know where the queen is, because it's all ordered in the exact same way. When you open a brand new deck of cards, it's always ordered in the exact same way, and that's how you're going to get it every time. So this is the system where it has the least amount of entropy, where everything can basically be predicted, where you know where everything is. Now, as we shuffle the deck, let's say we shuffle it just once, we have already increased the entropy. Why? If we're talking about just the disorder argument, then we can look at it with, well, the cards are more disordered. But scientifically, like mathematically, what's happening is we are less likely to predict where every card is. Now, as we continue to shuffle and shuffle and shuffle, and we keep shuffling, when do we achieve this maximum entropy? Because that's also something that we should maybe touch on. Because every system has a maximum entropy that it can achieve. And in this deck of cards, the maximum entropy will be achieved when each card has an equally likely outcome of being pulled. So let's say I put all the deck, all the cards face down after shuffling them like 100 million times, and I put them all face down. If the probability of me picking a king of hearts is the same as the probability of me picking a two of hearts or a two of spades, or any card, any two cards have the same probability, that is maximum entropy. That means it has been disordered to the maximum possible amount. it can't be disordered anymore, right? Because when you already have them at equal probability, how can you can't disorder it in any more way. So I think the deck of cards is the standard example that everyone gives when you're asking, can you like explain entropy to me? And also because I think it's an easy analogy.